Okay, so for these few examples, I'm going to show you the some questions that will require you to draw to visualize. So generally in this topic, if the question didn't draw the circle for you, you'll be advisable that you draw so that you can see certain things. So for example, here, if you look at example 6, we got a circle with center. So we know the center. We do not know the radius. So in equation of a circle, we need to know two things. I need the center and I need the radius. But I only got the center. So if I don't draw, I wouldn't be able to tell where is the center. So I'm going to draw, do a little bit of just a little bit of sketch. Okay, so the description is the circle is going to touch the x-axis. So it's going to be something like this. It's going to be touched. So touching the x-axis. So when it touches the x-axis, actually this is called a tangent. Touching the x-axis essentially is like the x-axis is a tangent. It's a tangent to circle. So if you already learn property of circles, there will be a property of circle for like radius is perpendicular to tangent. So this is the radius. This is the radius that is perpendicular to the tangent. So if you have not learned it yet, then you just have to pick up the property first. So radius is perpendicular to tangent. The x-axis is the tangent. And because of this, you can see that it's actually 5 units. So after you draw out, you realize that the center is given to you. Then the radius is 5 units. And then you can get the equation. Okay, then you just go for the expansion or leave it in the standard format. Okay, so that is, you need to visualize, and there's actually a property here. The property is radius perpendicular to tangent. So if the circle is touching the y-axis, then the y-axis and the radius will be perpendicular. So there is a, if it's circle, the other property has to be mixed in sometimes. So sometimes most of you will, if you come to this topic, you should have done your property of circles already. Otherwise, you got to apply, see it like a property. Okay, then the next one is a circle with diameter. So, okay, this one to me is a very clear-cut thing, but I realized that sometimes some students, they actually forgot the property of a diameter. So what is the thing about diameter? So what can we qualify from a diameter? So if a diameter is given, that means, right, the midpoint is the center. So that means the center is on the diameter. So from here, I will know that if I want to get the center, it will be the midpoint of AB. So you apply the midpoint. So this one is 4 minus 3. Okay, I'm just drawing randomly, so it doesn't match. Okay, so to me, it's just I apply the concept of diameter. Half of the diameter will be the center. So you apply your midpoint formula. So you gotten the center. And because these two are the endpoint of diameter, if I apply the length formula, so don't forget, this is what you have learned. So I apply the length formula on AB. I will get the length of the diameter. So you apply length formula. Hopefully you don't forget your length formula. So you get something like this. And because you can get your diameter to get the radius, you just divide by 2. So with the center and radius, you will be able to get the equation. Okay, so that's one of the more easier one. So don't forget that half of the diameter is actually radius, the midpoint is the center. Okay, so the next one, we deal with the tangent. We deal with tangent. Okay, so if you are dealing with tangent, you also need one of the property from property of circles. So radius is perpendicular to tangent. Okay, so that is the property that we need to know. So I'm just going to draw a random circle. I'm just going to draw a random circle. From here, you can see the center. So I'm not drawing accurately. I'm just doing a rough sketch. And then they say P is a point here. So P is here. So I'm supposed to get the tangent here. So this is the equation that I'm supposed to find. So if I need the equation, you will need mx plus c. You will always need a gradient and a point. So this is the tangent. So I have the point 37, but I don't have the gradient. So I actually need to create my gradient. So this is like my M1, and then this one is like my M2. I need to know that they are perpendicular. So radius is perpendicular to tangent, and because of this, I will have my M1 and M2. So from here, I get my center, I get my M1. So M1 is 5 minus 7, and minus 1 minus 3. So I get a half. So I apply the formula. M2 is the tangent that I wanted. So if you apply that, your gradient of tangent will be a minus 2. So this gradient is minus 2. So once you got the gradient and then you got the point, you just do your mx plus d. So that will be the equation of tangent. So it's very repetitive. You realize that you keep using m1 times m2 equal to minus 1 if there is a perpendicular thing. Okay, so the next question is the line x equal to minus 1 a tangent to the circle? So in actual fact, right, if you take a look, actually the line x equal to minus 1 will be here because the coordinate is like this. So visually, we can see that it is not going to be a tangent. But because you need to explain, you can explain through calculation. So you can explain through calculation. So I'm going to do a simultaneous of the line with the equation. So being a tangent means, right, it will just touch the circle. That means there's only one intersection. So I'm going to be explaining through the calculation. So I'm going to do a simultaneous. So if I do a simultaneous, so this will be a 0, and I will got something like this. So in actual fact, I will get two possible answers. So you will realize that there are two intersections. So when you try to do a simultaneous, there are two intersections. So since there are two intersections, our conclusion will be x equal to minus 1 is not a tangent. So in fact, the description should be x equal to -1, cut the circle at 2 points. Okay, so that's how you explain such thing. So the tangent has a perpendicular property. The next one also got a perpendicular property. So there is a chord here. Okay, so the midpoint of a chord. So it is also related to one of the property of circle. So one of the property of circle is there is a chord, and from the center, it will cut the chord at the midpoint. So remember, this part is the perpendicular bisecting chord. So obviously, I need to get the center and radius first. Okay, so do your usual step, get your center. So I'm not going to show the steps. So I will get my center as this, my radius is 5. So I'm going to draw to match the property. So this one is the chord, and then this one is the midpoint. So this midpoint is 2, 3, and the center is 3, 1. So I'm not drawing to scale. I'm just drawing it like to fit the property. So again, this one is M1, and then the gradient of the chord will be M2. So M1 times M2 will be equal to a -1. So I need to find the equation of the chord, which means I need the gradient of the chord and I need 1 point. So anyway, the point is already been found. So I need to do my M1 first. So my M1 will be 3 minus 1, 2 minus 3. Then I apply the formula, perpendicular gradient. So when I apply this, that will be a gradient half. So the chord is a gradient half. So gradient half and the coordinates. Okay, do your MX first, please. So the strategy doesn't change. So you realize that as long as it's perpendicular, I will use the formula. And equation is always MX plus C. You need a gradient and a point. So these are the few questions that involve property of circles, and also it helps that you actually draw it up. So generally, if a question doesn't draw for you, do draw it up. It will help in the visualization.